All right, in this video, I'm going to be walking you through the ALEKS assignment for November 3rd. So this will be on writing equations of linear functions in standard form and writing equations of parallel lines and perpendicular lines. Okay, to start, so if we're ever, hopefully we get this by now from our lessons, but if we're ever being asked to write an equation, right, for linear equations, we're always going to start with point-slope form, which is the one with parentheses. We're always going to start with point-slope form, and if we're going to write point-slope form, we must have a point. So of the points we're given, we have to pick a point. So here, let's say I'm going to go with -1, 6, and then I'm going to have to find the slope, okay, which is the m. So I have to find slope because I already have the point. So to find the slope, I'm just going to stack up these 2 points and subtract them. So I'm going to subtract -1 minus 5, that'll be -6, and 6 minus -4 is 10, and slope is the subtraction of the y, so that'll be 10 on top of the subtraction of the x's, which is -6. And if I can simplify, I should simplify, so this simplifies to negative. There's only one negative, so one negative is negative. If there were two negatives, that would make it positive, right? So this simplifies to -5 over 3. So my slope is -5 over 3. That goes where I replace the m with -5 over 3. And then this point is my x1 and my y1, right? So -1 goes where x1 is, and next to the x, and y1 goes where the y1 is, right? The x value goes with the x, and the y value goes with y. I just have to remember that when I plug it into the equation, this point gets opposite signs. So in this case, it would be y minus 6. In parentheses, it would be x plus 1 because I'm giving -1 opposite signs and I'm giving 6 opposite signs, right? And since they didn't specify what form, I'm able just to leave it in point-slope form. So that'll be my answer. All right. So moving on to number 2, same thing. We're writing an equation, so we're going to write an equation. So we're going to write it in point-slope form. And since I'm writing point-slope form, I need a point and I need the slope. So I can pick either of these points. So I've got a point right here. So this is 6, 6. That point is 6, 6. So that is going to be what I'm using. And slope is pretty easy to find on a graph, right? Because as long as I have the 2 points that touch a corner of a square, between those 2 points, I'm going to make a staircase, one big staircase. And my slope is rise over run. We just have to remember that we have to consider if it's a positive slope, which this one's a positive slope, or a negative slope, right? If it's a negative slope and you don't put a negative, it's going to be wrong, okay? Your answer will come out wrong. So my rise here is 12 and my run is 10. So rise over run is 12 over 10, and this can be simplified to 6 over 5. All right, so I'm ready to write my equation. This will be y minus 6 equals my slope, x minus 6. All right, and that'll be your answer. It does not specify a form, so you can leave it in point slope form. Going on to 3. Here we are going, right, with parentheses is point slope form. So we're going from point slope form. They're asking for from point slope form to write it into this form where x and y are together. They're asking for x and y to be together. That is standard form. Okay. So they want us to go from point slope form to standard form. That means we have to go from point slope to slope intercept to standard. Okay, and then there's 3 steps, right? We need to distribute. We need to get y alone. And then we have to move the x. All right, so let's do those 3 steps. I'm going to split this. So very similar to solving equations from chapter 1, right? I'm going to distribute the slope so that I'm getting rid of the parentheses. So I'm doing 6 times x, which is negative 6x, and negative 6 times negative 6, 2 negatives make a positive, 36. Okay, so that was my first step. I distributed. Now I'm going to get y alone, sorry. So to get y alone, I have to get rid of the plus 4 by subtracting 4. And I can only subtract the 4. Since I subtracted 4 on the left, I must do it to the right. And I can only subtract 4 from its like term. So 36 and 4 are like terms. I cannot subtract 4 from the negative 6x because negative 6 has an x, right? That would make it not like terms. So I'm left with y equals negative 6x plus 32. And now this is in slope-intercept form. I have one more step. So I need to move this x. So to move the x, I have to get rid of negative 6x by either adding or subtracting on the right, right? So to get rid of negative 6x on the right, I'm going to add 6x. And when I do to one side, I have to do to the other, and this will effectively move the x to the left. So this will be y plus 6x, right? Because I can't actually add y and 6x because they're not like terms. So I'm just going to put them next to each other. And bringing down 32, I'm done. I have my standard form. Let's see if the next question has fractions so I can show you how to clear the denominator. All right, so same. We're going to do the same steps. Because this is with parentheses, we're going from point slope to slope intercept. If you're starting from slope intercept, like say you start with an equation where y is alone, you only have that one step, the one step of moving the x by adding or subtracting it on the right, and then that'll move it to the left. Okay, here we go. Okay. We got y minus 3 equals 5, x plus 1. So first step is to distribute. So 5 times x is 5x, 5 times 1 is 5. And then I'm going to get y alone by adding this 3. That'll effectively get rid of the minus 3. And I'm left with y equals 5x plus 8. Okay. Dang, there's not going to be any fractions here. Okay, and then I have one more step. So this is slope-intercept. To get to standard form, I have to move the x. So I have to get rid of the x on the right by adding or subtracting to get rid of it. So I'm going to subtract 5x. And that'll, what I do to one side, I must do to the other. And that effectively moves it to the left side. And I'm going to bring down the 8. And that is my answer in standard form. Let's say this is the answer, but let's say I had a fraction. Okay, let's say it was a fraction. If it was a fraction, and we know that integers, right, means whole numbers, like not fractions. To get rid of the denominator, we're going to take whatever is in the denominator and we're going to multiply by that number. We're going to multiply all the terms by that number, and that would effectively give us all integers, right? No denominator, no fractions. Okay, that's just an example in case you did have a fraction, okay? Great, moving on. Number 5. So a line passes blah, 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 blah. Okay, so as long as we're writing a line, we're always going to start with point slope form. So as long as we're writing a line, an equation of a line, we're going to start in point slope form, okay? And in this example, they very conveniently gave us a point and a slope. So the point, the x of the point is going to go next to the x, and the y of the point is going to go next to the y, and they're going to get opposite signs. And my slope m goes right outside of the parentheses. All right, so this is point slope form. But they are asking for standard form. So they're asking for standard form, which is when x and y are together. So we have to go from point slope to slope intercept to standard. Okay, and we have those 3 steps. We're going to distribute. We're going to get y alone. And we're going to move the x. Right? So here we go. We're going to distribute. Doing -3 times x, which is -3x. And -3 times -2. 2 negatives make a positive 6. Okay, and then I'm going to get y alone by getting rid of this -5 by adding 5 to both sides. And I'm only allowed to add 5 to its like term, so I can only add it to the 6. I'm going to bring down the y and the -3x, and that'll be y equals -3x plus 11. And my last step is to move the x. So I'm going to get rid of the -3x by adding or subtracting. So in this case, I'm going to add 3x, doing its inverse. And I will have my standard form. This is the answer. This is the answer for standard form. Okay. Moving on to 6. Same. We're writing standard form. Right. This is standard form. However, we always start with point slope form. So conveniently, they gave us our point. The x goes next to x, the y goes next to y, and they get opposite signs. The slope is 8, which replaces m, right? And then we have our 3 steps to go from point slope to slope-intercept to standard. 3 steps are distribute, get y alone, and then move x. Okay, so distribute, we're doing x 8 times x, which is 8x, and 8 times -1, which is -8. Then I'm going to get y alone by getting rid of the +4. So I'm going to subtract 4. And I'm left with y equals 8x minus 12. And lastly, I want to move x by adding or subtracting 8x on the right to get rid of it. So in this case, I'm going to subtract. I'm going to do the inverse of 8x. I'm going to subtract 8x to both sides. Y and -8x aren't actually like terms, so we can't actually subtract them, but we can put them next to each other. And yep, that's our final answer. Moving on to 7. Same thing here. Starting off, so they want it in standard forms, but we're going to start from point slope form. So our point -4, -5, the -4 goes next to the x, and then -5 goes next to the y, but they get opposite signs. And the slope -5/2 goes outside the parentheses. And we're going to do our 3 steps. We're going to distribute. So we're distributing. We're going to get y alone. And then we're going to move the x on the right. So we're going to get rid of the x on the right by adding or subtracting. I'm going to do the inverse. So in this case, it would be add 5/2x. And so we get y plus 5/2x equals -15. However, they do want it as integers, right? They want no fractions. So if they want no fractions, and I have a fraction here, I'm going to take what I have in the denominator, which is 2, and I'm going to multiply all the terms by 2. So y times 2 is 2y. 5/2 x times 2 is 5x. And -15 times 2 is -30. Okay, and this is our final answer without fractions. Was that a positive 5x? Yep, positive 5x. Okay, moving on to 8. Okay. Here we have a point, and we don't have to do this every time, but let's just do it for this one time, so we can visualize what we're talking about here. So we have a point 7. We have a point 7,5. So if I have this point 7,5, and I put a vertical line through it, right? If you don't remember what vertical is, think of a basketball player checking their vertical jump, right? Vertical is up and down. Okay, a vertical line. If I put a vertical line through this point, this vertical line goes through the x-axis at 7. So this line, this vertical line, is x equals 7 because it goes through the x-axis at 7. Okay, we didn't actually have to draw this picture because we know that the x value of this point was 7, but just so we can visualize it. So the equation of the vertical line is x equals 7. And then if we drew a horizontal line, horizontal, think of the horizon. The horizon is like a line that goes side to side. If we drew a horizontal line through the point, the equation for this line would be y, because it's going through the y-axis. It's going through the y-axis at 5. Okay, so the horizontal line would be y equals 5, and the vertical line would be x equals 7, right? And we can do that in the next problem without even drawing the picture, because we can just look at the point. Oh, just kidding. Oh, I guess there's just one question. Okay, moving on. Okay, now we're gonna actually get into parallel and perpendicular, okay? Okay, parallel and perpendicular. What to know about parallel and perpendicular, what to remember? Parallel lines are lines that never touch, and they never touch because their slope are the same. Okay, and then perpendicular lines are interesting because they touch at one point and they make a perfect like right angle. Like the two lines make a perfect T. Okay, and the reason why they make a right angle, or the reason why they're perpendicular, is because their slopes are exact opposites. And they're opposite reciprocals. And what do I mean by that? I mean, if I have a slope that is, let's say the slope is 2, okay? 2 as a fraction is 2 over 1. And we know if there's no sign, it's positive, okay? The opposite reciprocal of positive 2, or positive 2 over 1, would be negative 1 over 2, right? They get opposite signs and the fraction is flipped. That's what reciprocal means. Okay, so if the slopes are the same, like 2 and 2, then they're parallel. If the slopes are opposite reciprocals, then they're perpendicular, okay? So that's what we're checking here. We're going to find the slopes of each line and then just compare them. We're going to say if they're parallel or perpendicular. Do they have the same slope or do they have opposite reciprocals? Okay, I'm just to find the slope, we're just gonna stack up these points and subtract. -3 minus -1 is -2. -2 minus -4 is -6. And slope is a change of the y on top of the change of the x. So it'll be -6 on top of -2, which simplifies to +3, right? Two negative makes a +3. Okay, next one. We're going to subtract. -1 minus 0 is -1. -2 minus 1 is -3. Slope is a change of the y on top of the change of the x, so it'll be -3 on top of -1, which is +3 as well. So here we've got parallel lines because they're the same. And lastly, we're going to subtract 3 minus -6, which is 9, -3, no, sorry, -6 minus -3, which is -3. So the change of the y on top of the change of the x, which would be -3 over 9, 1 negative is just negative, and this simplifies to 1 over 3. All right. So 3, 3, and negative 1/3. Okay. So lines 1 and 2 are parallel because they're the same. Lines 1 and 3 are perpendicular because they're opposite signs and flipped, right? Because 3 as a whole number as a fraction is 3 over 1. So 1/3 is the reciprocal. And lines 2 and 3 are also perpendicular because this is positive 3 over 1 and this is negative 1 over 3, right? It's a negative reciprocal. Okay, I think the rest of these questions are all parallel and perpendicular. Let's see. I'm going to do the same thing. We're going to find the slope of line 1. So I'm just subtracting here. And I do the subtraction of y on top of the subtraction of x. I'm going to do the slope of line 2. I'm going to do the subtraction of y on top of the subtraction of x, which is, there's one negative, so that'll be negative 5 over 4. It simplifies. In the third line, negative 8 minus negative 4 is negative 4. And 8 minus 3 is 5. I'm going to do the subtraction of the y on top of the subtraction of the x. And that is already simplified. And it looks like we have all parallel lines. So I would say they're all parallel because they all have the same slope. They're all negative 5 over 4. Okay, moving on. Okay. Fun. Okay. So what is the slope of the parallel line? And what is the slope of the perpendicular line? So we're talking about this line's slope. What is this line's slope? Well, this line, where y is alone, is in slope-intercept form, which is y equals mx plus b. So that means the slope m is right in front of the x, and in this case, it's an invisible 1. So the slope of this equation is 1. What is the parallel slope? Well, I know parallel slopes have the same slope, so it would be 1 as well. And what would be the perpendicular slope? Well, I'm going to take this 1, positive 1, and I'm going to make it negative. And I know that this is 1 as a fraction, would be 1 over 1. So if I flip 1 over 1, I would still get 1 over 1. So that's the slope of the parallel is 1. And the perpendicular would be negative 1 over 1. Going on to 12. Same thing. This is when y is alone. This is slope-intercept form. So this is y equals mx plus b. Right? Remember that the slope m is in front of the x, mushed against the x. So in this case, the number mushed against the x is negative 6. Or as a fraction, that would be negative 6 over 1. Okay? So what would be the parallel slope? That would be negative 6 over 1 because same slope. And the perpendicular slope which is opposite reciprocal, which means I change the sign and I flip the fraction. I'm going to make this positive, and I'm going to flip the fraction to be 1 over 6. Okay, next one, 13. Now we're just writing equations. So let's figure out the slope here. This, where y is alone. This is slope-intercept form, which is y equals mx plus b. So our slope here, m, is mushed against the x, which is positive 7 over 8. So our parallel slope would be positive 7 over 8, and our perpendicular slope would be negative 8 over 7, right? Give it opposite signs and flip it. So if I had to write an equation with this slope for parallel, with this slope and this point, I'm going to do point slope form, because we always start with point slope form, and we can just leave it in point slope form. That would be y minus 5 equals 7 over 8, parentheses x minus 7. And if I had to write a line with an equation with this point and this perpendicular slope, it would be y minus 5 equals negative 8 over 7, parentheses x minus 7, right? And that's all we had to do there. 14. We're going to do the same thing, however, this time, right, this is in standard form. And something about standard is that it tells us 0 information. I'm so sad. Does not tell us slope. Okay, so what we have to do is we have to go from standard to slope intercept, right? And there's 2 steps, unfortunately. There's 2 steps. There's the exciting move. We're going to move the x, and then we're going to do the great divide. So essentially, it's 2 steps, but essentially we are just solving for y. Essentially, we're just solving for y. So if I'm solving for y, I'm going to move the x, the 3x. I'm going to move the x by getting rid of the 3x on the left. So if I want to get rid of the 3x by adding, subtracting, I'm going to subtract 3x on both sides. I'm going to be left with negative 7 minus 3x. And the second step, the last step, would be to do the great divide, meaning I'm going to divide everything by negative 7, right? So my goal here is to get y alone so that I have slope-intercept form. Right, that's what we're trying to do. So if I do negative 7 divided by negative 7, that'll be 1. If I do negative 3 divided by negative 7, 2 negatives make a positive, and 3 divided by 7 is just 3 over 7x. Okay, so now we have slope-intercept, which is y equals mx plus b. So our slope here is 3 over 7. Our parallel, let's start with our parallel slope would be 3 over 7. Our perpendicular slope would be negative 7 over 3. We give it opposite sign, then we flip it. Okay, so the equation using this point for perpendicular would be y plus 4 equals negative 7 over 3, parentheses x plus 3. And the parallel equation would be y plus 4 equals, using this point, right, equals 3 over 7, parentheses x plus 3 for the parallel. Okay, it was a lot of work for 2 equations, but we'll keep on practicing this, right? Okay. Question 15, probably the same thing. What is the slope of the parallel? Okay, this is the same thing, okay? Same thing, but we don't have to write the equation, we just have to find the slope, okay? So here, where x and y are together, this is standard form. And standard form tells us nothing. It does not tell us the slope. So we have to go from standard to slope-intercept to find the slope. Okay, so we have our 2 steps. We're going to move the x, the exciting move, and we're going to do the great divide. Okay, so we're moving the x, we're going to subtract 2x from both sides. That gets rid of it on the right. We're going to do the great divide. So we're going to divide everything by 6. So we're left with y equals 5 divided by 6 is 5 over 6. And negative 2 over 6 is negative 2 over 6. Or you could also simplify it to negative 1 over 3. So here now we have slope-intercept, which is y, which is y equals mx plus b. We know our slope. Our slope is mushed against the x, so in this case it would be negative 1 over 3. Okay, so what would be the parallel slope? It would be the same slope. What would be the perpendicular? It would be opposite sign, reciprocal. All right, almost done here. Question 16. We're doing the same thing. Okay, so this is standard because x and y are together. Standard does not tell us the slope. So we have to go from a standard to slope-intercept with 2 steps. We're going to do the exciting move, which is to move x, and we're going to do the great divide. I'm going to move the x. I'm going to do the great divide. So we're going to divide everything by 9 because our ultimate goal is to have y alone, which is when we have slope-intercept form. So we're just going to do 4 divided by 9 and negative 6 divided by 9. That's 1 negative 6 over 9 simplifies to 2 over 3. Okay, and our slope here, because it's y equals mx plus b, our slope m is mushed against the x. So our slope m is going to be negative 2 over 3. So our parallel slope would be the same slope, and our perpendicular would be the opposite reciprocal. So we go from negative to positive, and we flip 2 over 3 to be 3 over 2. Okay, 17. Now we have to find the slope of all of these lines and then just compare them. Okay, so line 1. You got 2y equals negative 3x plus 5. That is not quite slope-intercept. So we want to get this to slope-intercept by getting y alone. How do we get y alone? Well, we're going to divide everything by 2. We're going to do the great divide. So this will be negative 3x divided by 2 is negative 3 over 2x. And 5 divided by 2 is just 5 over 2. Right? So our slope here, because this is now slope-intercept, is negative 3 over 2. Okay, this one is standard form, so we have 2 steps. We're going to move the x, and do the great divide. So divide everything by 4. So negative 8 divided by 4 is negative 2. And negative 6 divided by 4 is negative 6 over 4, but simplifies to 3 over 2. And so our slope here, because now this is slope-intercept form, the number mushed against the x is negative 3 over 2. Okay, so now we have parallel slopes. Line 1 and 2 are parallel. Okay, and now let's do line 3. Line 3 is y equals negative 3 over 2x minus 7. This is already in slope-intercept form because y is already alone. So our slope, which is mushed against the x, is negative 3 over 2. Great, so they all have the same slopes. They're all parallel. Moving on to 18. Same thing. So we're just getting all of these equations into slope-intercept form. So we're just solving for y for all of them. Okay, so we're going to move the x. And we're going to do the great divide. We're going to divide everything by negative 6. So we get negative 4 divided by negative 6 is negative 4 over 6. So we can just leave it like that. We don't have to simplify. It's fine. And then negative 4x divided by negative 6. So negative divided by negative is positive 4 over 6, which is just 4 over 6. Or we can simplify it to 2 over 3x. So our slope here is positive 2 over 3 because once we have slope-intercept form, the slope is mushed against the x, right? Let's do line 2. We have 2y equals negative 3x plus 3. So y is almost alone. So we're just going to divide 2. We're going to divide everything by 2 to get y alone. So negative 3x divided by 2 is negative 3 over 2x. 3 divided by 2 is also 3 over 2. And our slope here, which is mushed against the x, is negative 3 over 2. And lastly, so these two lines are perpendicular. 1 and 2 are perpendicular because one's positive, the other one's negative, and one's 2 over 3, and the other is 3 over 2. Okay, last one. We got y equals negative 3 over 2x plus 7. So this one is this one's already in slope-intercept form because y is already alone. So our slope is negative 3 over 2. Okay, because in slope-intercept, the slope's mushed against the x, right? So lines 1 and 3, again, are also perpendicular because one's positive, the other one's negative, and one's 2 over 3, the other is 3 over 2. And then lines 2 and 3 are the same, so they are parallel. All right, and that's it for today. Let me know if you have any further questions.